Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So today we continue our lecture with chapter 2, electric power generation technologies. Before that, we recite Surah Al-Fatihah. Okay, so this is the contents of chapter 2, which consists of first is the introduction on the electric power generation. Okay, and then we go to the conventional power generation technologies, which is the existing power generation technologies that have been implemented, especially in Malaysia. And then the renewable energy sources, which is the energy sources that replace the existing power generation technologies nowadays. And then we have the distributed generations, which is the DGs. And finally, some of the economics of power generation. So starting with introduction. So what is electricity generation system? As I mentioned in our previous class regarding the electricity generation system, is the process of generating electric power from the energy sources. So as you can see here, we have here is the starting from the generation power plant, and then go to the step-up transformer. Normally in Malaysia is from 11 kV to 132 kV, and it goes to the transmission line. The transmission substation goes to the distribution part. Okay, and then we have the step-down transformer here, and then go to the loads, which is the residential house, the industrial, the commercial, and etc. Okay. Same goes to this one. Okay, this is the overview of the modern electricity power system. So starting with the electric generating resources. Okay, from here we can see there's a solar and also wind. This one is called as the renewable energy. Okay, and then after that we have the transmission lines. Okay, the receiving station normally is the transmission main intake, and it go to the distribution substation. So normally it is main distribution substation, and it goes to the various types of the loads, which is the commercial, industrial, and also residential. Okay, this is the statistical review of world energy in 2017. So here we can see, okay, Malaysia. So Malaysia electricity generation has increased from 2006 to 2015. So this shows that the trend of Malaysia electricity generation keep on increasing time year by year. Okay. Okay, sources of electric energy has two, which are the conventional or primary sources. Okay, this one, the conventional or the primary sources, and the second one is the renewable or secondary sources. For the conventional or primary sources, we divide to two parts, which is fossil fuels and also nuclear power. So conventional power plant is the general term applied to the production of electric energy from coal, oil, which is the diesel or petroleum, or natural gas using the intermediary of steam. Okay. Okay. Meanwhile, the renewable or the secondary sources is the energy that is collected from renewable resources, which are naturally replenished on a human time scale, such as hydropower, geothermal power, solar power, tidal power, wind power, and biomass. So this is the performance and statistical information on electricity supply industry in Malaysia in 2015 from the Energy Commission data. So you can see here, this is the electricity generation by energy source. So we have 6 types of generators, utilities, which is the TNB, the IPP, independent power producer, and then renewable energy, public cogeneration, private cogeneration, self-generation. Okay, so we have here is the natural gas, the coal, hydro, diesel, biomass, solar, biogas, mini hydro, distillate, others. Okay, so this is the electricity generation by energy source from different types of the generators. Okay. Okay, coal plays a vital role in electricity generation worldwide. Coal-fired power plants currently fuel 38% of global electricity, and in some countries, coal fuels a higher percentage of electricity. Okay, same goes to Malaysia. So coal is a fossil fuel that extracted from the ground, and this coal had been used since the Industrial Revolution. It is preferred to be used because it is easy to be used because they require simple direct combustion. Okay. Okay. Next conventional energy sources is the natural gas. So natural gas is a fossil energy source that formed deep beneath in the Earth's surface. Natural gas contains many different compounds, and the largest component of natural gas is the methane. Okay, methane. It is a compound with 1 carbon atom and 4 hydrogen atoms, which written as like this. Okay, this is we call as a methane. Okay. Okay, next conventional electric energy source is the nuclear power. Nuclear power is the use of nuclear reactions that release nuclear energy to generate heat, which most frequently is then used in steam turbines to produce electricity in a nuclear power plant, as shown in this figure. Okay, so nuclear power can be obtained from nuclear fission, nuclear decay, and nuclear fusion reactions. So in this figure, it shows nuclear method of the nuclear fission. Okay. Okay. In nuclear fission, atoms are split apart, which releases energy. All nuclear power plants use nuclear fission, and most nuclear power plants use uranium atoms. Okay, so during this nuclear fission, normally neutron will collide with the uranium atom. Okay, so and then it will then split its releasing a large amount of energy in the form of heat and radiation. So neutron plus collide with the uranium will resultant of producing barium, krypton, neutron, and also the energy. This is the energy that form of heat and radiation. Okay. Okay, this is where the nuclear fission happens, and then it will produce, these nuclear power plants will produce the heat. Okay, from the nuclear fission it will produce the heat, and then this heat will hit the water to produce steam. Okay, and then the steam is used to spin the large turbines and then generate the electricity. Okay, that is the about the nuclear power. Okay, now we continue with the types of the renewable energy sources. Okay, first is the hydropower. So hydroelectric power is produced with moving water. Because the source of hydroelectric power is water, hydroelectric power plants are usually located on or near a water source. Okay, the volume of the water flow and the change in elevation or fall and often referred to as heat from one point to another. From one point, okay, uh, from one point to another, okay, will determine the amount of available energy in moving water. So in general, the greater the water flow and the higher the heat, the more electricity a hydropower can produce. Okay, so greater water flow and higher, okay, higher heat. This one we produce more electricity. Okay. Okay, second types of renewable energy is the wind power. So wind power or wind energy is the use of wind to provide mechanical power through wind turbines to turn electric generators. Okay, so wind power is a sustainable renewable energy source that has a much smaller impact on the environmental compared to the burning fossil fuels. Okay, the third renewable energy source is the solar power, and it is very popular compared to others renewable energy. So solar power is the conversion of energy from the sunlight into electricity, either directly using the photovoltaics. This one is the photovoltaic cells. Indirectly using the concentrated solar power or a combination. So these photovoltaic cells convert light into an electric current using the photovoltaic effect. Okay, and then the second one, we have the concentrated solar power systems. If we use the lens of or mirrors and solar tracking system to focus a large area of sunlight into a small beam. Okay. Okay, next is the biomass. Biomass is plant or animal material used for energy production, okay, or in various industrial processes as raw substance for a range of products. So it can purposely grown energy crops, wood or forest residues, waste from food crops, horticulture, food processing, animal farming, or human waste from sewage plants. Okay, so from all those biomass products, you can use to produce heat and then produce steam, and after that finally we can produce the electricity. Okay. Okay, this one is the Tenaga Nasional Berhad Power Stations in Peninsular Malaysia. So you can see here we have the thermal station and also the hydro station. In Sungai Perak hydro, and then Kenyir we have hydro also. Parker gas turbine combined cycle, Cameron Highlands hydro, and etc. Okay. So next, we go to the conventional power generation technologies. Okay, so there are two power plants that will be discussed in this section, which are the coal-fired power plant and also the gas turbine and combined cycle power plant. So we look at the first power plant, which is the coal-fired power plant. Okay, so it will cover about the introduction of the coal-fired power plant, We will see on the traditional coal-fired power plant, the emission control for the traditional coal-fired power plant, and then we go for the advanced coal-fired power plant, and finally the environmental effects of coal. Okay, so first we start with the introduction. What is coal? Okay, coal is a combustible black or brownish black sedimentary rock formed as rock strata called coal seams. Okay, coal is mostly carbon with various amounts of other elements such as we have hydrogen, sulphur, oxygen, and nitrogen. Okay, coal is formed when dead plant matter decays into peat and is converted into coal by the heat and pressure of deep burial over millions of years. Okay, there are several types of coal which depending on the depth and location of the seam. Coal is classified into 4 main types or ranks. Okay, we have the anthracite, the bituminous, subbituminous, and lignite. Okay, so the ranking depends on the types and amounts of carbon that coal contains and on the amount of heat energy the coal can produce. The rank of a coal deposit is determined by the amount of pressure and heat that acted on the plants over the time. Okay, we look on one about the types of coals. The first one is lignite. Lignite contains 25% to 35% of carbon. Okay, 25% to 35% of carbon, and has the lowest energy content of all coal ranks. Okay, so lignite coal deposits tend to be relatively the youngest coal and were not subject to extreme heat or pressure. So lignite is crumbly and has high water content, and also it contributes to low heating values. Okay, so these types of coal has many impurities and not preferable type to be used. Okay, next is the subbituminous. Subbituminous coal, typically it contains around 35% to 45% of carbon, and it has a lower heating value than bituminous coal. Okay, so this subbituminous coal is more cheaper because it is not deep as bituminous coal, and it contains less sulfur than lignite. Okay, next is the bituminous coal. So bituminous coal contains about 45% to 86% of carbon. Okay, and this bituminous coal is the most abundant rank of coal. Okay, it has a high heating value, but it also has a high sulfur content. Bituminous coal is used to generate electricity, and it is an important fuel and raw material for making cooking coal or used in the iron and steel industry. Okay, the next one is the anthracite coal. So anthracite coal contains 86% to 97% of carbon and generally has the highest heating value of all ranks of coal. Okay, it is a very hot coal which burns longer with more heat and with less dust, and this is the popular home heating fuel. So this shows about the percentage of carbon contained in all types of the coal. For example, for the lignite is around 30% of carbon, subbituminous 40% of carbon, bituminous 50 to 70% of carbon, and anthracite 90% carbon, as I mentioned before. Okay, this show the traditional coal-fired power plant. So this is the main structure. So the process of the coal to turn to the electricity is starting from the first one is heat is created. Okay, so first the coal here, you can see here. So coal is pulverized into a fine powder by a large grinder. Okay, and then this ensures nearly complete burning of the coal in order to maximize the heat given off and to minimize pollutants. Okay, then the pulverized coal is then input to the boiler. So the coal will be delivered to the boiler. Okay, so where combustion occurs and the coal provides heat to the power plant. Okay, so heat is created. This one is the first process. The second process is water turns to steam. Okay, so this heat is transferred to the pipes containing high pressured water, which boils to steam here. Okay, so it happens here. It will produce the steam. Okay, so the steam then travels through a turbine. Okay, steam number third process is the steam that travels to a turbine here. Okay, causing it to rotate extremely fast, which in turn spins a generator and producing electricity. Okay, the electricity can be input to the electrical grid for use by the society. So in this, the third process, we have the steam will turn the turbine. Okay, the enormous pressure of the steam pushing against a series of giant turbine blades turns the turbine shaft, and then the turbine shaft is connected to the shaft of the generator, where magnet spins within wire coils to produce the electricity. Okay, after that, the final process is the steam will turn back into the water. Okay, here, turn back to the water. So the steam is drawn into condenser, a large chamber in the basement of the power plant. So millions of gallons of cool water from nearby source, such as river or lake, are pumped through a network of tubes running through the condenser. And then the cool water in the tubes converts the steam back into the water that can be used over and over again in the plant. Okay, so this is the complete process of producing the electricity from the traditional coal-fired power plant. Okay, this is the figure of the giant steam turbine blades that turns the turbine shaft. Okay. Okay, this is the detailed explanation of the process of coal power generation. So you can read to increase your knowledge about the process on how to turn coal to electricity. Okay, so this is the energy conversion that involved in the coal-fired power stations. So the energy conversions that take place in a coal-fired power plant are as follows. First step is the chemical potential energy in the form of coal, and then goes to the heat energy or thermal energy, and then goes to the kinetic energy or mechanical energy, okay, from the turbine, and then finally goes to the electrical energy, which is produce the alternating current in the stator. So every time energy is converted from one form into another form, there will be a great amount of it is lost during the conversion. So the less energy conversion steps, therefore the more efficient the production of electricity becomes. Okay. Okay, next is the emission control for traditional coal-fired power plant. So we look on the types of emission that produce from the combustion of coal. So the combustion of coal to generate energy is an inherently dirty process. Okay, so the combustion products from the traditional coal burning power plant are the carbon dioxide, the nitrogen oxide, and also the sulfur dioxide. So, in addition, incombustible mineral material in the coal is left as ash and slag. Okay, some mineral and particulate material escapes with the flue gas that contain trace metals such as mercury, which are potentially harmful. Okay, so this is the data of the coal contribute in 2010. The coal contributed about 81% of carbon dioxide emissions from generation and contributed about 45% of the electricity generated in the United States. Okay. Okay. The control strategies for the traditional coal burning power plant. This is the emission control. So the first one is the coal treatment. Okay. So when coal is burned to produce energy, its chemical makeup is changed and sulfur is released. To avoid environmental problems with the sulfur, normally the coal companies and power plants take measures to remove it before, during, and after burning process. Okay, so in pre-combustion technologies before burning process, the coal may be cleaned at the mine, at the power plant, or both. Okay. So when the coal is cleaned at the mine preparation plants, it is crushed and washed. So, this effort can significantly reduce the levels of sulfur emissions, and in addition, it can also reducing the amount of ash and slag produced. So next is the low nitrogen oxides burner. Okay, so low nitrogen oxides burner. So nitrogen oxides are generated by reaction between oxygen and nitrogen contained in the air during the combustion process. So this nitrogen oxide production is strongly affected by two factors. The first factor is temperature at which the combustion takes place. And the second factor is the amount of oxygen available during the combustion process. So if we can control these two parameters, therefore we can control the production of the nitrogen oxides. Okay, so this can be achieved by using the low nitrogen oxide burner. So this burner has been designed to create an initial combustion region for the pulverized coal particles where the proportion of oxygen is kept low. Okay. The third one is the new method called sulfur dioxide removal that has been developed. Okay, so there are no strategies similar to low nitrogen oxide burner that can be used to control the emission of sulfur dioxide. So sulfur in coal will be converted into sulfur dioxide during the combustion process. So the only recourse is to capture the sulfur either before the coal is burnt using a coal cleaning. So in this sulfur dioxide removal, we use some chemical reagent, which is the lime and limestone, inside the power plant, and that resultant particles of calcium sulfate. This is the cheapest method, but not the most efficient. So it is around 30% to 90% capture efficiency, depending on the point of injection of the sorbent. So inject one of these sorbent materials into the flue gas stream as it exits the furnace. Okay. The best established method is called a flue gas desulfurization or FGD unit. Also, we call as a wet scrubber. So the efficiency is around 97% to 99%. The FGD unit comprises a specially constructed chamber through which the flue gas passes. So a slurry water containing 10% of lime or limestone is sprayed into the flue gas when it reacts, capturing the sulfur dioxide. The slurry containing both gypsum and unreacted lime or limestone is then collected at the bottom of the chamber and will be recycled. Okay, this is the figure of the flue gas desulfurization or FGD. Okay, in a flue gas desulfurization system FGD, sulfur compounds are removed from the exhaust emissions of fossil fuel power stations. Okay, so this is done by means of an industrial process through the addition of the absorbents. So this is the additional absorbents. Okay, so this process can remove up to 95% of the sulfur dioxide from the flue gas. So the wet process has become the main method of the FGDs in large fossil fuel power plants. So in this method, the flue gas are steam saturated with the absorbent in aqueous solution. Normally substances such as ammonia, sodium sulfide, lime or limestone slurry has been used as the absorbents. So the unclean flue gas is sprayed in a scrubber tower. This is the scrubber tower or the absorber tower with a mixture of the water and also the limestone. Okay, whereby most of the sulfur dioxide is bonded by the chemical reaction, and then it will produce the clean gas. Okay, so after a number of chemical reactions, a gypsum, okay, this one is gypsum, is finally produced in a suspension. After dewatering, this leaves gypsum with up to 10% residual moisture, which provides a valuable product for the construction material industry. So this is the overview of the process of the FGD process. So the fourth method is by using the carbon dioxide removal. Okay, so the primary combustible component of a coal is carbon. So when carbon burns completely in the air, it is turned into carbon dioxide. So a number of methods for capturing the carbon dioxide, which are the chemical absorption, the physical absorption, and the membrane separation. So the first one is the chemical absorption. Okay, first is the chemical absorption in order to capture the carbon dioxide. This method will use a chemical such as monothenolamine MEA or potassium carbonate, okay, to capture and bind the carbon dioxide. And then the second one is the physical absorption. So absorbing the carbon dioxide within a solid compound which is placed in its path in the flue gas stream at low pressure. And finally, the membrane separation, exploiting the properties of a special membrane which will allow carbon dioxide to pass through it but will not pass the oxygen or the nitrogen. Okay. And then the fifth method is by using the particulate or mercury removal. So there are two principles for removing the particulates of mercury from the flue gas of the coal-fired power plant, which are the electrostatic precipitators or ESPs and also the fabric backhouse filters. Okay, so this is the figure of the electrostatic precipitators, ESPs, and the second one, okay, and then the second one, so this one is the ESPs, and then the next one is the fabric filters in order to remove the particulates of mercury in the flue gas. Okay, so we look on to the electrostatic precipitators, ESPs. Okay, so this ESPs was invented by the American scientist Frederick Cottrell. So if you can see here, it utilized a system of plates and wires to apply a large voltage across the flue gas as it passes through the precipitator chamber. Okay, so this causes an electrostatic charge to build up on the solid particles in the flue gas. As a result, they are attracted to the oppositely charged plates of the ESP where they collect. And then ESPs capture up to around 50% of the mercury emitted by a power plant. Okay. And then the second methods is by using the fabric backhouse filters. Okay. So these methods also known as a back filters. It is a tube-shaped filter bags through which the flue gas passes. So particles in the gas streams are trapped in the fabric of the bags, from which they are removed using one of the variety of a bag cleaning procedures, and it is extremely effective by removing over 99% of the particulate material or the mercury. Okay, this is the explanation. You can read. Okay, next is the advanced coal burning power plants. So before this, I have informed of you about the traditional coal burning power plant. So therefore, they have improved the traditional coal burning power plant and introduced the advanced to overcome the limitation of the existing or the traditional coal burning power plant. So there are two important technologies that have been introduced, which are the Fluidized Bed Combustion or FBC, and also Integrated Gasification Combined Cycle or IGCC. Okay. Okay, the first method is the Fluidized Bed Combustion, which is the FBC method. So FBC method, fluidized bed suspends solid fuels in upward blowing jets of air during the combustion process. So you can see here, it used the fluidized bed. Okay, so here, this is the fluidized bed. Okay, the result is a turbulent mixing of gas and solid. Okay, here, happens here. So the tumbling action, much like a bubbling fluid, provides more effective reactions and heat transfer. So instead of use the combustion process, it used the fluidized bed method. Okay. So and then you can see here, the coal is only contains around 5%. Okay, 5%. So the remainder of the bed is primarily an inert material such as ash and also sand. Okay, so the temperature in the fluidized bed is around 950 degrees Celsius. Okay, in here is 950 degrees Celsius, significantly lower than the temperature in the traditional coal boiler. So therefore, it can help minimize the production of nitrogen oxide. Okay. And then you can see also here we have the limestone. So the reactant such as limestone also is added to the bed in order to capture the sulfur. Therefore, it can reduce the amount of sulfur dioxide released into the exhaust gas. So this is the process of FBC method. Okay, so this is the explanation about the FBC method. Okay, so this is the video that I will share with you later on. Okay, so the next method is Integrated Gasification Combined Cycle or IGCC. So this is the figure of the IGCC. Okay, this is a figure of the Integrated Gasification Combined Cycle or IGCC. So an IGCC is a technology that uses a gasifier to turn coal and other carbon-based fuels into gas. So you can see here, this is the gasifier, okay, the first process. So it will produce the synthesis gas or syngas. Okay, so syngas, a mixture of hydrogen and carbon monoxide. So it then removes impurities from the syngas. So it produces a clean syngas, step number 2, and then the gas produced meanwhile is cleaned and can be burned in a gas turbine, the step number 3, to produce electricity. Okay, and then the heat in the exhaust, you can see here from number 3, the exhaust heat from the combustion turbine is recovered to generate additional steam. Okay, go for the process number 4 at the heat recovery steam generator. It will produce additional steam. Process number 5. And then this steam, along with that, from the synthesis gas process, then drives a steam turbine here, generator, to produce additional electricity. So IGCC is a combined cycle from the gasifier and also the recovery steam generated to produce electricity. Okay, so an IGCC power plant can achieve an efficiency of 45%, and it can remove 99% of sulfur from the coal and reduce the emissions of the nitrogen oxide. And then further development is a design and effective technologies for cleaning the hot exhaust gas before it enters the gas turbine stage of the IGCC plant. And hot gas cleanup will allow an IGCC plant to operate at minimum efficiency. Okay, there are several environmental effects from the coal power plant. So first is the coal mining causes severe erosion, resulting leaching of toxic chemicals into the nearby streams. Okay, secondly is the coal burning produce sulfur dioxide, carbon dioxide emissions, and also nitrogen oxides emissions. So if you look here, nitrogen oxides, okay, so the nitrogen oxides will exacerbate asthma, reduce lung function, and cause respiratory disease. Next is the sulfur dioxide and nitrogen oxides, both combine with water in the atmosphere to create acid rain that will killing off plants, fish, and the animals. And finally, global warming is mainly caused by the carbon dioxide emissions. So this is the tutorial that you can try to answer these simple questions. First one, explain with your words the basic operation of coal power plant based on your understanding. And the second is list down the emission produced by the coal power plant. And then the third one is discuss the methods in order to mitigate the pollution from coal power generation.